Hi guys, tonight we're exploring something absolutely extraordinary. What if you could suddenly see in every spectrum of light? Infrared, ultraviolet, radio waves, X-rays, gamma rays. Imagine your eyes opening to a universe of invisible energy that's been surrounding you your entire life. If you enjoy these sensory-expanding sleep stories that reveal hidden dimensions of reality, hit that like button and subscribe for more. And drop a comment letting me know what time it is, where you are, and where you're listening from. I enjoy seeing where my global audience is tuning in from. Alright, let's begin. Imagine standing in your bedroom this morning, reaching for the light switch with the casual indifference of countless mornings before, when suddenly the world explodes into a symphony of invisible radiance that has surrounded you your entire life without your knowledge. The walls around you pulse with infrared heat signatures, painting thermal maps of every pipe running through your home, every electrical current flowing behind drywall, every breath you've exhaled still lingering as warm clouds in the cool morning air. Above your head, radio waves from cell towers 8 kilometers away streak through the ceiling in brilliant ribbons of electromagnetic energy, while microwaves from your neighbor's morning coffee ritual pierce through the shared wall like luminous spears. This is the moment humanity gains the ability to perceive the entire electromagnetic spectrum, from radio waves stretching over 10,000 kilometers in length, down to gamma rays smaller than the nucleus of an atom, and nothing will ever be the same again. The electromagnetic spectrum spans an almost incomprehensible range of frequencies and wavelengths, extending from extremely low-frequency radio waves at 3 Hz up to gamma rays exceeding 10 to the 19th Hz. Currently, human vision captures only a tiny sliver of this vast continuum, roughly 400 to 700 nanometers in wavelength, representing less than 1% of the total spectrum. We exist in a state of cosmic blindness, perceiving our universe through a keyhole, while an entire cathedral of light blazes around us undetected. The average human eye contains approximately 6 million cone cells and 120 million rod cells, sophisticated biological instruments that have evolved to detect photons within this narrow visible range with remarkable precision. Yet this represents an almost tragic limitation when we consider that the universe communicates through electromagnetic radiation across 40 orders of magnitude in frequency. In the first moments after gaining spectrum-wide vision, the sensory overload would be overwhelming. The human brain, which dedicates roughly 30% of its cortical area to processing visual information, would suddenly receive data streams millions of times more complex than anything it has evolved to handle. Radio astronomy facilities like the Arecibo Observatory in Puerto Rico, before its collapse in 2020, detected radio signals from galaxies 13 billion light-years away, capturing electromagnetic whispers from the edge of the observable universe. With spectrum-wide vision, every human would become a walking radio telescope, able to perceive these cosmic conversations streaming through their bodies at every moment. The immediate revelation would transform our understanding of seemingly empty space. What appears as vacuum contains a constant flood of electromagnetic energy at every frequency. Cell phone towers broadcasting at 850 MHz would become brilliant beacons visible from 50 kilometers away, their signals propagating outward in perfect spheres of light. Wi-Fi networks operating at 2.4 GHz would paint buildings in complex interference patterns, creating a digital aurora around every connected device. The average smartphone emits approximately 2 watts of radio frequency power, which would appear as bright as a flashlight in this new visual paradigm. Walking through a modern city would reveal the invisible infrastructure of our technological civilization in stunning detail. Power lines carrying 60 Hz, Alternating current would glow like neon tubes stretching across the urban landscape, with transformer substations blazing like miniature suns at 460 kilovolts. The electrical grid of New York City consumes approximately 11,000 megawatts during peak demand, creating an electromagnetic signature visible from space. High-voltage transmission lines would appear as brilliant highways of energy, with the 765 kilovolt lines connecting major power plants resembling lightning bolts frozen in perpetual illumination. The hidden heat signatures of the world would paint every surface in thermal poetry. Building insulation would reveal its effectiveness through infrared patterns, with energy leaks appearing as bright spots bleeding warmth into the atmosphere. The average human body radiates approximately 100 watts of heat at a peak wavelength of 9.4 micrometers, making every person a gentle beacon in the infrared spectrum. Urban heat islands, where cities can be 6 degrees Celsius warmer than surrounding areas, would become visually obvious as massive thermal domes rising above metropolitan regions. Medical implications of spectrum-wide vision would revolutionize healthcare overnight. X-rays naturally occurring from cosmic radiation bombard Earth at a rate of approximately 200 particles per square meter per second, allowing humans to peer inside living bodies without mechanical intervention. Tumors, with their characteristic heat signatures from increased metabolic activity, would be detectable as infrared bright spots within the body. Cardiovascular disease could be diagnosed by observing the heat patterns of blood circulation, while broken bones would show as disruptions in the natural electromagnetic fields generated by piezoelectric effects in healthy bone tissue. The ability to see ultraviolet light would unveil a secret world of biological communication. Many flowers display ultraviolet patterns invisible to human eyes, but clearly visible to pollinating insects. Approximately 88% of flowering plants rely on animal pollinators, and many have evolved intricate UV landing strips and nectar guides that would suddenly become apparent to human observers. The sun emits roughly 400 watts per square meter of UV radiation at Earth's distance, creating a harsh ultraviolet landscape that would reveal the protective power of our atmosphere's ozone layer as a shimmering shield filtering deadly radiation. International security and surveillance would be transformed beyond recognition. Military stealth technology, designed to minimize radar signatures, would become visually apparent to any observer capable of seeing radio frequencies. The B-2 Spirit stealth bomber, costing $2.2 billion per aircraft, achieves its low observability through carefully designed angular surfaces that deflect radar energy away from the transmitter. With spectrum-wide vision, these reflections would be clearly visible, rendering traditional stealth concepts obsolete. Submarine detection through extremely low-frequency radio waves, currently requiring massive antenna arrays spanning dozens of kilometers, could be accomplished by individual human observers. The night sky would be transformed into a cosmic light show of unprecedented beauty and complexity. Radio galaxies like Centaurus A, located 11 million light-years away, emit radio waves across frequencies from 10 MHz to 100 GHz, with a total radio luminosity of 10 to the 39 watts. These cosmic powerhouses would dominate the radio sky like brilliant stars invisible to current human perception. Pulsars, rotating neutron stars with magnetic fields trillions of times stronger than Earth's, would appear as lighthouse beacons sweeping across the sky at precisely timed intervals. The pulsar in the Crab Nebula, 6,500 light-years distant, rotates 33 times per second and would create a mesmerizing strobe effect across multiple electromagnetic frequencies. Jupiter's magnetosphere, extending up to 7 million kilometers from the planet, generates radio emissions so powerful they can be detected with simple amateur radio equipment on Earth. With spectrum-wide vision, Jupiter would appear as a massive radio beacon even during daylight hours, its emissions caused by interactions between its magnetic field and charged particles from its moon Io. Saturn's radio emissions discovered by the Cassini spacecraft would create their own unique signature in the radio sky, generated by the planet's auroral processes. The revelation of cosmic microwave background radiation would provide humanity with direct visual access to the afterglow of the Big Bang itself. This radiation, discovered accidentally by Arno Penzias and Robert Wilson in 1964, permeates all of space with a nearly uniform temperature of 2.7 Kelvin, above absolute zero. Every cubic centimetre of space contains approximately 400 photons from this primordial radiation, representing the stretched and cooled remnants of the universe when it was only 380,000 years old and first became transparent to light. Agricultural and environmental monitoring would achieve unprecedented precision through spectrum-wide vision. Healthy vegetation reflects approximately 40 to 50% of near-infrared light, while absorbing most visible red light, creating a characteristic spectral signature used in satellite-based crop monitoring. The normalized difference vegetation index, calculated from red and near-infrared reflectances, would become visually apparent to human observers, allowing real-time assessment of crop health across vast agricultural regions. Global food production, currently feeding 7.8 billion people through cultivation over approximately 1.4 billion hectares of agricultural land, could be optimized through direct visual monitoring of plant stress, disease, and nutrient deficiencies. Forest fires would become visible long before current detection methods identify them, as burning vegetation produces characteristic infrared signatures detectable from orbit. NASA's moderate-resolution imaging spectroradiometer detects thermal anomalies associated with fires using 4-micrometer infrared radiation, technology that would be replicated in human vision. The Amazon rainforest, covering 5.5 million square kilometers and containing approximately 400 billion trees, could be monitored in real time for deforestation and illegal burning activities. Ocean temperatures and current patterns would become visually obvious through infrared perception. The Gulf Stream, transporting approximately 30 million cubic meters of warm water per second from the Gulf of Mexico toward Europe, would appear as a massive river of heat crossing the Atlantic Ocean. El Niño and La Niña phenomena, driven by temperature variations in Pacific Ocean surface waters of just 2 to 3 degrees Celsius, would be immediately apparent to spectrum-wide vision, allowing improved prediction of global weather patterns affecting billions of people. The hidden world of atmospheric science would unfold in spectacular detail. Water vapor, invisible to normal human vision but strongly absorbing infrared radiation at wavelengths around 6 micrometers, would reveal the three-dimensional structure of humidity throughout the atmosphere. Weather systems would appear as vast rivers and whirlpools of moisture, with hurricanes displaying their characteristic spiral structure through water vapor patterns. The average hurricane contains energy equivalent to exploding a 10-megaton nuclear bomb every 20 minutes, energy that would be partially visible through its electromagnetic signature across multiple spectral bands. Urban planning and architecture would be revolutionized by the ability to directly observe energy efficiency and thermal performance of buildings. The Empire State Building in New York City consumes approximately 40 million kilowatt-hours of electricity annually, energy that would be visible as patterns of electromagnetic emission across the structure. Heat loss through windows, which accounts for 25 to 30% of heating and cooling energy used in typical buildings, would be immediately apparent through infrared vision, enabling optimization of insulation and energy systems. Transportation infrastructure would reveal its electromagnetic signatures in fascinating detail. Automotive radar systems operating at 77 GHz for collision avoidance would create a network of scanning beams visible across highway systems. Electric vehicles would display their electromagnetic fields differently from internal combustion engines, with the Tesla Model S battery pack containing approximately 7,000 individual lithium-ion cells generating distinct electromagnetic patterns during charging and operation. The aviation industry would face fundamental changes as aircraft navigation and communication systems become visually apparent to spectrum-wide observers. Commercial aircraft typically carry multiple radar transponders operating at 1.03 GHz, creating bright electromagnetic signatures visible for hundreds of kilometers. Air traffic control radar systems, operating with peak power outputs of 25 kilowatts, would paint the sky with sweeping beams of microwave radiation, tracking aircraft positions with precision measured in meters. International communications infrastructure would become a visible web connecting the global community. Submarine telecommunications cables, carrying approximately 99% of international internet traffic along 450 cables spanning 1.3 million kilometers of ocean floor, would be trackable through their electromagnetic emissions at signal amplification points. Satellite communication networks would appear as brilliant beacons in geostationary orbit 35,786 kilometers above the equator, with individual satellites transmitting kilowatts of microwave power to Earth-based receivers. The implications for privacy and surveillance would be profound and troubling. Every electronic device emits characteristic electromagnetic signatures that would become visible to spectrum-wide vision. Smartphones, laptops, and wireless devices would betray their locations and operational status through their radio frequency emissions. The NSA's Tempest program, which monitors electromagnetic emissions from electronic equipment to reconstruct information being processed, would become accessible to any observer with spectrum-wide vision. Computer monitors operating at frequencies around 70 MHz would display their content as electromagnetic patterns potentially readable from significant distances. Space exploration and astronomy would advance by centuries in mere moments. The cosmic ray background, consisting of high-energy particles constantly bombarding Earth's atmosphere at rates of approximately 1,000 particles per square meter per second, would become visible as a constant shower of gamma-ray signatures. These particles, originating from supernova, black holes, and other cosmic phenomena, carry energies up to 10 to the 20th electron volts, making them the highest energy photons in the universe. Black holes would become visible through their accretion disks, where matter spiraling into the gravitational abyss heats to billions of degrees and emits X-rays across a broad spectrum. The supermassive black hole at the center of our galaxy, Sagittarius A star, with a mass 4.1 million times that of our Sun, would appear as a brilliant X-ray source 26,000 light-years away. Its event horizon, with a Schwarzschild radius of approximately 12 million kilometers, marks the boundary beyond which electromagnetic radiation cannot escape, creating a dark shadow against the brilliant accretion disk. Neutron stars with surface temperatures reaching 1 million Kelvin and magnetic fields up to 100 trillion times Earth's would blaze across multiple electromagnetic frequencies. These stellar remnants, containing the mass of our Sun compressed into a sphere 20 kilometers in diameter, achieve densities where a teaspoon of neutron star material would weigh approximately 1 billion tons. Their electromagnetic emissions span from radio waves to gamma rays, creating some of the most energetic phenomena in the observable universe. The search for extraterrestrial intelligence would be transformed by spectrum-wide vision. radio telescopes like the Very Large Array in New Mexico, consisting of 27 antenna dishes each 25 meters in diameter, currently search for artificial signals from other civilizations across frequencies from 74 MHz to 50 GHz. With human spectrum-wide vision, every person would become a SETI detector capable of identifying artificial electromagnetic signatures that might indicate technological civilizations elsewhere in the galaxy. Industrial processes would reveal their electromagnetic fingerprints with unprecedented clarity. Steel production facilities, consuming approximately 20 gigajoules of energy per ton of steel produced, would display complex patterns of infrared emission during smelting and forming operations. Chemical plants would show the thermal signatures of exothermic and endothermic reactions, with temperature variations revealing process efficiency and potential safety hazards. The global steel industry, producing approximately 1.8 billion tons annually, would become visually apparent through its electromagnetic emissions across industrial regions worldwide. Nuclear facilities would display their characteristic gamma-ray signatures, making reactor operations visually apparent through their radiation shielding. Nuclear power plants, generating approximately 10% of global electricity through 440 reactors worldwide, produce gamma radiation that would be visible through concrete containment structures. The Chernobyl exclusion zone, still emitting elevated levels of gamma radiation 37 years after the disaster, would appear as a glowing region of electromagnetic contamination spanning approximately 2,600 square kilometers. Weather modification and atmospheric research would benefit enormously from direct observation of electromagnetic phenomena. Lightning, generating electromagnetic pulses across frequencies from very low frequency up to very high frequency bands, would be visible as spectacular electromagnetic displays. Each lightning stroke carries approximately 5 billion joules of energy and creates radio frequency emissions detectable thousands of kilometers away. Thunderstorms worldwide generate approximately 100 lightning flashes per second, creating a continuous global electromagnetic symphony currently invisible to human perception. The aurora borealis and aurora australis would become spectacular displays visible not just in polar regions but detectable through their radio frequency emissions worldwide. These phenomena are caused by solar wind particles interacting with Earth's magnetosphere, generate kilometric radio emissions and optical displays spanning altitudes from 80 to 1,000 kilometers above Earth's surface. Solar storms can inject up to 10 to the 15th watts of electromagnetic energy into Earth's magnetosphere, creating aurora displays visible as far south as the Caribbean during major geomagnetic events. Geological processes would reveal their electromagnetic signatures through various mechanisms. Earthquake prediction might become possible through observation of very low-frequency electromagnetic anomalies that some researchers believe precede seismic events. The Earth's magnetic field, generated by convection currents in the outer core approximately 3,000 kilometers below the surface, would be visible as field lines extending into space and protecting our planet from solar radiation. Magnetic field reversals, occurring on average every 450,000 years, would be detectable through gradual changes in the global electromagnetic pattern. Mining and resource exploration would be revolutionized by direct observation of subsurface electromagnetic properties. Different minerals and geological formations exhibit distinct electromagnetic signatures that ground-penetrating radar and electromagnetic surveys currently map indirectly. Gold deposits, often associated with specific resistivity patterns, might be detectable through their electromagnetic properties. The global gold mining industry, extracting approximately 3,400 tons annually, could locate new deposits through spectrum-wide vision of subsurface electromagnetic anomalies. underwater exploration would gain new dimensions through electromagnetic perception. Ocean water, with its high conductivity due to dissolved salts, creates unique electromagnetic propagation characteristics. Extremely low-frequency communications used for submarine contact penetrate seawater to depths of approximately 200 meters at 3 to 30 Hz frequencies. Marine life would display various electromagnetic signatures, from the electrical fields generated by fish muscle contractions to the bioelectric navigation systems of sharks and rays. The implications for human health and biology would be simultaneously beneficial and concerning. Electromagnetic hypersensitivity, reported by some individuals as adverse reactions to electromagnetic fields, would be directly observable rather than subjectively reported. The human nervous system, operating through electrical impulses typically ranging from 50 to 100 microvolts, would become partially visible through its electromagnetic emissions. Brain activity, generating electromagnetic fields detectable by electroencephalography at frequencies from 0.5 to 100 Hz, might be observable through spectrum-wide vision. Circadian rhythms influenced by light exposure across various wavelengths would be optimizable through precise control of the electromagnetic environment. Blue light at wavelengths around 480 nanometers suppresses melatonin production and regulates sleep-wake cycles, effects that would be directly observable in spectrum-wide vision. The modern epidemic of sleep disorders, affecting approximately 70 million Americans, might be addressed through better understanding of the electromagnetic influences on circadian biology. Food safety and agricultural monitoring would achieve unprecedented precision through electromagnetic analysis. Bacterial contamination often produces characteristic heat signatures and electromagnetic properties detectable through infrared and microwave frequencies. The annual burden of foodborne illness, affecting approximately 48 million Americans yearly, according to CDC estimates, could be reduced through real-time electromagnetic monitoring of food production and storage facilities. Climate change would become visually apparent through direct observation of atmospheric greenhouse gases. Carbon dioxide, while transparent to visible light, strongly absorbs infrared radiation at wavelengths around 15 micrometers. The current atmospheric concentration of 420 parts per million would be detectable through its infrared absorption signature, making the greenhouse effect directly observable. Methane emissions from agriculture, landfills, and fossil fuel extraction would be visible through their characteristic infrared absorption at 3.3 micrometers wavelength. The transformation of human society would be immediate and irreversible. Privacy as we know it would cease to exist, as electromagnetic emissions from personal devices would betray location, activity, and even physiological state. Electronic surveillance would become omnipresent, as every human would possess the ability to detect and potentially interpret electromagnetic signals from considerable distances. Democratic societies would face unprecedented challenges balancing security concerns with individual privacy rights. In a world where electromagnetic invisibility is impossible, educational systems would require complete restructuring to accommodate spectrum-wide vision. Children would need training from early ages to process and interpret the vast amounts of electromagnetic information suddenly available to human perception. The current educational focus on traditional literacy and numeracy would expand to include electromagnetic literacy, teaching students to understand and navigate the full spectrum of electromagnetic phenomena surrounding them. Economic disruption would be massive and immediate. Industries based on electromagnetic detection and measurement, worth hundreds of billions of dollars globally, would become obsolete overnight. Conversely, new industries would emerge to develop filters, interpreters, and management systems for spectrum-wide vision. The current telecommunications industry, with global revenues exceeding $1.4 trillion annually, would face fundamental restructuring as electromagnetic communications become directly observable by human vision. Art and aesthetics would be revolutionized as humanity gains access to new forms of beauty previously invisible to human perception. The electromagnetic landscape would become a new canvas for artistic expression, with artists manipulating radio waves, infrared patterns, and other electromagnetic phenomena to create works spanning the entire spectrum. Photography would expand beyond visible light to capture the full, electromagnetic reality of our universe. Religious and philosophical implications would challenge fundamental assumptions about reality and human perception. Many spiritual traditions speak of invisible realms and energies surrounding us, concepts that would gain new meaning when the invisible electromagnetic universe becomes visible. The revelation that we have existed our entire evolutionary history in a state of cosmic blindness would profoundly impact human understanding of our place in the universe. Scientific research would accelerate exponentially as 7.8 billion humans become walking research instruments capable of directly observing electromagnetic phenomena across all frequencies. The current limitation of expensive, specialized equipment would be eliminated, as human vision provides direct access to electromagnetic data, previously requiring billion-dollar facilities to observe. Citizen science would take on new meaning when every human possesses superhuman electromagnetic perception capabilities. In the end, the gift of spectrum-wide vision would represent both humanity's greatest achievement and its greatest challenge. We would gain access to the full electromagnetic symphony of our universe, while losing forever the innocent simplicity of our current limited perception. The visible universe would expand by factors of millions, revealing beauty and complexity beyond current imagination, while simultaneously exposing every electromagnetic secret of our technological civilization. As we stand on the threshold of this transformation, we can only imagine how profoundly it would reshape every aspect of human existence, from the most intimate personal moments to the grandest cosmic observations, forever changing what it means to be human in an electromagnetically transparent universe.